Welcome to the Podkey summary of Create Web Extensions for Safari from WWDC 2026. Today's story is really about how Safari extensions fit into Apple's world without turning into their own weird little island. The big themes are packaging, privacy, and portability. How developers wrap an extension in an app for the App Store, how the same web extension code can now travel pretty cleanly across browsers, and how Safari handles things like blocking rules, permissions, storage, and even Touch ID. If you build browser extensions, or you're just curious why Safari works the way it does, this is a pretty good snapshot of where things stand. The first thing to know is that Safari does not ship extensions the way Chrome does. You're not tossing out a standalone browser package and calling it a day. In Safari, the extension gets bundled inside a native macOS or iOS app, and that whole thing goes through the App Store. That sounds heavier. And honestly, it is a different mental model. But Apple has a tool called the Safari Web Extension Packager to smooth it out. That packager can create the Xcode project, wrap the extension resources, and basically turn web extension files into something App Store ready. One practical detail here is nice. Developers can submit the packaged app from any browser through Apple's distribution flow, so the upload step itself does not require sitting at a Mac with Xcode open. The more encouraging part is that Safari is not trying to make developers rewrite everything from scratch. Apple is part of the W3C Web Extensions Working Group, alongside the broader effort to keep extension APIs lined up across Safari, Chrome, and Edge. So if a developer already has a web extension, a lot of the core pieces can carry over with minimal changes. The manifest.json, the HTML, the CSS, the JavaScript. That matters because duplicate effort is how ecosystems stay small. If porting is painful, people skip it. If it's manageable, Safari gets more extensions and users get more choice. A lot of this comes down to the declarative net request API, which is one of the big building blocks for content filtering. Instead of constantly running logic in the background and inspecting every request in real time, the extension declares rules ahead of time. Those rules can block requests, redirect them, or modify them, and Safari can apply them efficiently because the browser is doing the heavy lifting from a defined rule set. There are static rules in the manifest, and there are dynamic rules added at runtime, which is where things get useful for real people. If a user wants to maintain their own block list, the extension can map each host to a rule ID and update that live rule set with update dynamic rules whenever a site gets added or removed. Safari also draws a pretty firm line around privacy and access. There's a difference between plain declarative net request and declarative net request with host access. For some blocking behavior, the extension does not need host access at all. But if it wants redirect rules that involve reading or acting on specific sites, then explicit host permission comes into play. And Apple makes that visible. If an extension asks for optional host access at runtime, Safari shows a badge and a permission prompt. If the user grants it, the icon gets tinted, which is a simple but useful signal that the extension is active on that page. It's one of those small interface choices that quietly answers, wait, what has access here? There's a similar idea with content scripts. Instead of declaring every content script statically up front, developers can register them on the fly for sites that matter, like hosts a user has added to a block list. The Registered Content Scripts API lets the extension assign an ID and choose whether the script should persist across Safari restarts. If that persistence flag is set to true, the registration survives a browser relaunch, which is exactly what you want for normal everyday use. But there's one catch. Those scripts do not automatically survive an extension update. So after an update, the extension needs to register them again. That's where storage and lifecycle handling come in, and this is the sort of detail that makes an extension feel solid instead of flaky. Safari offers session storage for temporary data and local storage for persistence on disk. If the block list and mode settings go into local storage, they survive reloads and browser restarts, and the UI can immediately show the save state when it opens again. Then there's the background environment. Developers can use a background page, or a service worker, and both can listen for the on-installed event. That event is especially handy after an update, because the extension can read the stored hosts and re-register the dynamic content scripts it needs, so functionality doesn't quietly disappear. Some developers still like background pages because they have DOM access. But either way, the key is making sure updates don't wipe out the behavior users were counting on. One of the more interesting pieces here is native messaging. If the extension includes the native messaging permission, it can send a message to the bundled native app through Safari WebExtension handler. That native side can then call the system biometric API. So before a user changes something sensitive like a block list, the app can ask for Touch ID authentication. The flow is simple in spirit. The JavaScript sends the request. The native app handles the biometric check, and then it sends back success or failure. It's a nice example of Apple's approach in one little feature. The extension gets web-style flexibility, but it can still hook into platform security when that actually helps. Once the extension is packaged, the distribution path is the familiar Apple one. Developers join the Apple Developer Program, create an app entry in App Store Connect, choose the platforms they want, like iOS, macOS, and visionOS, and upload the package build. TestFlight is there for beta distribution and feedback, and the distribution tab is where the screenshots, descriptions, and rest of the store listing get finished up. Because the extension is fundamentally built with HTML, CSS, and JavaScript, that same codebase can reach iPhone, iPad, Mac, and Apple Vision Pro. The packaging process handles the right bundle identifiers for each platform, and after installation, the extension shows up in Safari's extension settings across those devices. So the overall picture is pretty clear. Safari's model is more app-shaped than Chrome's, but the trade-off is tighter platform integration, clearer permission signals, and a realistic path to shipping the same extension across Apple's whole lineup. That's the roundup. A little more packaging, a lot less reinvention, and just enough permission tinting to remind you the browser is paying attention. Pretty reasonable deal, honestly. This episode was generated by Podkey. Create your own at podkey.fm.